Given an integer array nums, return the length of the longest strictly increasing subsequence. So here's an example. We have an array 0, 1, 0, 3, 2, 3, and the output should be 4.
All right, to understand the problem, we're given a smaller input. Let's say we have an array of 1, 10, 2, and 3. The expected answer is 3, which you can tell from 1, 2, and 3. However, there are a lot of possibilities to get the answer for this. For example, we can take 1 and 10, and that will give us a longest increasing value of 10 of 2. But we can't include 2 and 3 because 10 is bigger than 2 and 3. Alternatively, we could take 1, we can skip 10, and go straight to 2. And then from 2 to 3, that'll give us a length of 3. Notice a pattern with what we did earlier, where we essentially either took a number or we didn't take a number. And this is represented in this graph where all of our left subtrees is what happens when we take the current number. For example, we're at -1, just our starting value, and our current value is 1. We can decide to take 1, and then our next value would be 10, which is represented in our graph. Alternatively, we have our right subtree, which is when we don't take the current number. So in this example, we have -1. We decide not to take 1, and in our next subtree, we're still at -1, but our next current value is 10. If we were to define this problem into code, for all recursive problems, we have our base case and our recursive case. For our base case, when we know that we finally reached an answer at the end is when we reach the end of our array. So this is represented by the B at the very bottom. When we reach the end, we'll just return 0. And for a recursive case, which is when we are still trying to find our base case, we only have 2 options, which is 1, take the current number, which is the left subtree, or we don't take the current number, which is the right subtree. Now let's walk through the problem to get an idea of how this will work. Because it's a dynamic programming question, we need to cache our state to be able to efficiently run our algorithm. The recursive solution will still be the same. The only big difference is that we'll have a cache, which is represented by our matrix right here, to help us keep track of the answers that we calculated, so that when we see the same state all over again, we can just reuse the value instead of recalculating it. For example, we see right here, we have 10, 2. That reappears right here on this right subtree. So instead of recalculating all of our possible answers here, we can just reuse the value that we saved. First, we start off at our top node, -1, 1. -1 is nothing, it's just a starting value. We start at our current value, which is 1 in our array. At this point, we have 2 choices. We can either take the 1, or we can go to the left subtree, or we can not take the 1 and just continue going to the right subtree. Let's just take the 1 for now. So that brings us to our next possibility. We're at 1, and we have the choice to either take the value at 10, or we can skip it. Right now, we'll just continue along and we'll take it. Now we are at current value 10, our next value is 2. Unfortunately, 10 is larger than 2, so we can't take the value. So we have no choice but to just skip it, which brings us to 10.3. Same thing here, we can't do anything, and then we reach 10b, or 10 in our base case, which is the end of the array. At the end of our array, in our base case, we know we reached the end, so we can just return 0, which we can bring back up here. At 10.3, we also return 0 because there's no other answer. We can also remember, because it's a DP problem, we should store the value inside our cache. At previous value 10, and at the current value 3, we've calculated 0. So we'll just add that in our cache. And then we go back to 10.2, and we do the exact same thing. And then, because 10.2, yeah, same thing with 10.2, we just return that back up. When we take the 10, we have a length of 0 plus 1, which represents our us taking the value 10. 0 plus 1, which gives us 1 on the left subtree. Before we continue going back up, we have to try going the right subtree when we skip the 10. That will bring us to 1, 2. We're still at the same previous highest value 1 with the minimum take 2. We're at the same previous value 1, and we're at the current index thing here. We have the choice to take 2 or not take 2. If we take 2, we'll be right here, where our previous value is 2, and our next value is 3. We take 3, and that brings us to one of our base case right here, where we reach the end of our array, and that will return 0 plus 1 from taking that 3. And then, of course, the next thing we can do is we can take our base case, or we can take 2. And then, of course, we visit the right subtree where we don't take 3, bring us back to our other base case, which once again, we return 0. So finally, now that we have both of the subtrees, we can tell that we have a maximum of 1 right here, giving us a longest sequence for our previous value at 2, at the current value 3, a total, a max of 1. We move this 1 back up, plus another 1 to account for the 2 that we previously used. And that gives us 2 from the left subtree. And of course, we continue on the right side. We don't take the 2, we get take 2. And okay, take 2, we do. And then we go up to the right subtree where we don't take the 2 and we get 1, 3. We do something very similar. Both sides, we take the 3 and that gives us 0 plus 1. And we don't take the 3 and that just reached our base case. That gives us 1. So back up here at 1, 2, we are comparing our max, or we are comparing 2 versus 1. That would give us, and the maximum of that is 2. So our base, in our cache, we would store 1, 2, have the value of 2. We bring this back up here, 2, and at 1, 10, we know that our maximum value is 2. And then finally, now that we know it's 2, we take 2 plus 1, which accounts for us taking the 1 in the first place, and that would give us a total of 3 for the left subtree of -1, 1. Now, I won't go through the whole process of the right subtree from this point, but let's say we continue to -110, we take 10, and we reach here. At this point, we already know the answer to that at 10, 2, which gives us 0. So this subtree will always return 0 back up, and that will apply the same for everything on the right subtree, which would eventually are all zeros, and this would all return 0, which eventually would bring us back up to our starting node, which is what the max of what happens if we take 1, which gives us 3, versus what happens if we skip 1, which gives us 0. And that would bring us the value 3 for our answer. Do this recursive. If we were to do this recursively without any caching, this would give us a runtime of O2 to the power of n, because we are, for all n numbers, we are making a decision of either including it or not including it, and that would branch out to a multitude of possibilities. Luckily, because we are caching it, we don't have to run this, and we only have a runtime of O to the power of n squared, because we only have to try at worst all n possibility times the remaining n possibilities to see to find all the possible combinations. And of course, because for space complexity, because we're using a matrix to calculate all of our states, we only have to store n squared possible combinations.
All right, let's get started. First, we're going to initialize our cache with -1. Now we need to iterate over each of the index inside our array, and we're going to compare and take the highest maximum subsequence length. Alright, so next we need to define our helpful methods by taking the nums, previous and current position, and we need to check our base case just to make sure it has not reached the end of our array, and we need to check if it's already calculated that in our cache. If so, we're going to just go ahead and return those values. And we're going to check if we can take the current position. If we can't, we're going to go ahead and skip that. However, if we can, we're going to go ahead and compare when we can take that position and when we skip that position. And we take whichever one return us the longest length. Lastly, we just need to return back the value. Alright, thanks for watching. Thumbs if you like it and sub if you love it.